Welcome to session on force. Focus on the screen. Consider a balloon which is free to move. Let us apply an external force using our index finger. This external force causes three effects on the balloon. One, it changes the size of the balloon, although very minimally. The balloon size will change. A dent will be caused at the point of application of force. Then the shape of the balloon will change. And next, if the balloon is free to move, a displacement is caused due to this external application of force. So the first two effects, size and shape, let us ignore. For the sake of study in physics, when we are studying basics, we consider all objects to be perfectly rigid. So therefore, any external force cannot change its size or shape. That is our assumption. So we can ignore the change in size or change in shape of the balloon. So we will assume that our entire external force is spent on causing displacement. So if the balloon is free to move, it will travel in a straight line. Like earlier it was here, so it will move to this point due to the application of force. Okay, so this motion where an external force causes a body to move along the application of force in a straight line, it is called linear motion. Okay, but suppose if the balloon is pivoted at this point and is not free to move, then the balloon will not undergo linear motion, but the balloon, since it is pivoted here, it will tend to rotate about this pivoted point. So this motion is called rotational motion or circular motion. So the linear motion we had already studied in standard 9, and we are not studying linear motion in 10th class. We are only concentrating on rotational motion. Okay, so now to clearly understand the force, first we need to look at momentum. In turn, we need to look at mass and velocity. What is meant by mass? Mass of any body is defined as matter comprised in the body that offers resistance to change of inertia. So every body comprises matter which might offer resistance to change in its inertia. Inertia again can be inertia of rest or inertia of motion. So if a body is at rest, if you are applying an external force, this force has to overcome the state of inertia, then only this body will start moving. If the body is already moving, then to stop this body, an external force is required. So if this body is comprised of mass, then comprised of matter, this matter will offer resistance to this change in inertia. Here, inertia of rest was changed to inertia of motion. Here, inertia of motion is changed to inertia of rest. So there is a change in state of inertia. So mass is defined as matter comprised in a body that offers resistance to this change of inertia. Okay. So the units of mass are kg in SI units and grams in CGS units. Okay. So now, what is velocity? Velocity is defined as rate of change of displacement. So, if a body is moving from point A to point B, it might follow any path, but the shortest distance between point A and point B is called displacement. This rate of change of displacement, that is displacement by time, that is change in displacement by time, this will give you velocity. Units of velocity is, in SI units it is meters per second, in CGS units it is centimeter per second. Practical unit is kilometers per hour. So is it clear? So now we understand what is mass and what is velocity. Now, what is momentum? Momentum of any body is defined as the product of its mass and the velocity with which it is traveling. So this product of mass of a body and its velocity is the quantity called momentum. The momentum is denoted by small letter p. We can't denote momentum by m because already m is used to denote mass. So momentum is denoted by small letter p. And the units of momentum is kg meter per second or gram centimeter per second. Clear? To get a sense of momentum, suppose a road roller is moving at a certain speed. A big road roller is moving at a certain speed, and a bicycle is also moving at the same speed. So a road roller mass is very high, whereas a bicycle mass is low. So although the velocity of road roller and bicycle are same, the road roller will have greater momentum than the momentum possessed by bicycle. Okay, so you got a sense of momentum. Okay, now this external force that we applied on the balloon is causing displacement of the balloon. Okay, so assume the balloon is traveling. Initially it was at this position in state of rest, so it started moving, and this is position 1, and it increased its velocity to position 2. Then again the velocity will decrease at position 3, and then it will come to rest. So we are only considering these two positions. So where there is velocity v1 and velocity v2. So here velocity of v2 is greater than v1. So this is the state or the condition or the process that we are considering. So when we had applied an external force using our index finger, so this is, if I am drawing a graph on x-axis, if I take time, so at this position there is the time, there is some time, and at this position there is another time t2. So the time taken from position 1 to 2 is t2 minus t1. We can call it as change in time t. So velocity also changed from v2 to v1, v1 to v2, sorry. So if I draw a graph on coordinate plane, on x-axis if I take time, and on y-axis if I take momentum, okay. So mass of the body balloon is same in at both the stages. So at point 1 here the momentum is mv1, or this we can call it as p1. So this is the p1. Okay. Similarly, the momentum at position 2 is mv2, where v2 is greater velocity, because we are assuming the balloon speed of the velocity of the balloon increased. So at this position the momentum is p2. Okay. So momentum has increased from p1 to p2. So this is the change in momentum, and during the time, this is the time interval during which the momentum has changed. This momentum changed due to the application of external force. Okay. So now how do you define force? Force is defined as rate of change of momentum. That means this is the change in momentum, rate of change of momentum by t. So this should be equal to mn. So force, mathematically, the definition of force, rate of change of momentum, mathematically we can write it as F is equal to change in momentum by time. So this gives an expression for force. Now suppose this, on this graph, a point A exists and I am blowing it up. Okay, so the vertical line, this is what P2 minus P1. Horizontal line, this is what T2 minus T1. So if I blow this A point, so the point is shown as some small line. So the vertical component of this line dp is infinitesimally small change in momentum. So it is denoted by delta p, or it is called dp. So infinitesimally small change in momentum, which is increase in momentum in this case, and this dt, that is the horizontal component at A, this is infinitesimally small change in time, or it is called dt. So from the definition of force, force is rate of change of momentum. So it can be written as change in momentum by time taken. Okay, so this I can write it as P2 minus P1. This is change in momentum by time. This, if I write T2 minus T1 as T, so this is T. Or when I consider at point A, see, because P2 minus P1 by T is nothing but tan theta. That is the slope of this line. Okay, so when at point A, I can write the same equation as infinitesimally small change in momentum by infinitesimally small change in time. So what does this mean? Rate of change of momentum. Or this I can write it as delta p by delta t. Okay. Now we know that momentum is product of mass into velocity. Okay. So I can write this above equation as mass into delta v by delta t. So this delta v by delta t is nothing but rate of change of velocity. It is delta v by delta t is nothing but acceleration. From the expression we see that it is rate of change of velocity, that is change in velocity per unit time, which is nothing but acceleration. So I can write F as m instead of dv by dt, I can write a. So F is equal to ma. So the external force applied can be obtained by as a product of mass and the acceleration caused in the body due to its application of force. So external force is defined as ma. F is equal to ma. This is the fundamental equation of force that you must remember. So the memory pack to remember is the greatest force on this planet is Mother Ma. So F is equal to ma. Remember it forever. Okay. Now, coming to units, consider you must have seen this mass of 1 kg while you are buying from a street side vegetable vendor. So this is actually mass. This mass is pulled towards the center of Earth using gravitational force G. So this force is denoted by kgf force. When they call kg, they are referring to only the mass. But when they call it as 1 kg weight or 1 kg force, then they are referring to this force with which this mass is pulled towards the Earth. So the force, the biggest unit of force is gravitational unit, that is kg force. Okay, and the next unit is in SI units, the unit is newtons. So newtons is another unit of force in SI system. So how do you define Newton? See, we got that F is equal to ma. This is the guiding equation. So how do you define 1 Newton force using this? So 1 Newton is the amount of force that can accelerate a body of 1 kg mass through 1 meter per second second square acceleration. So 1 Newton is the amount of force that can move 1 kg mass through 1 meter per second square acceleration. Similarly, in CGS unit, it is called 1 dyne. So how do you define 1 dyne? 1 dyne is the amount of force that is required to accelerate 1 gram of mass through 1 centimeter per second square acceleration. Okay, so the 3 units of force are gravitational unit kgf, which is the biggest. Then in SI units it is Newton. Then in CGS units it is dyne. Now the conversion of units, 1 kgf is equal to g times, because g is the gravitational force, g times Newton, or 1 kgf is equal to 9.81 newtons, or approximately, sometimes to simplify the calculations, it is given as 10 newtons. So in problems, if you are asked to assume 1 kgf is equal to 10 newtons, go for it, because if you take 9.81, you might end up with a difficult calculations that might waste your time in exam hall. So when you are assumed to make this assumption, go for it. Then 1 Newton is equal to 10 to the power 5 dyne. Okay, this is another relationship you should remember. How do we get it? Okay, so what is, by definition, 1 Newton can accelerate 1 kg of mass through 1 meter per second square acceleration. F is equal to ma, right? So 1 Newton is equal to 1 kg into 1 meter per second square. So if I convert this 1000 grams make 1 kg into, this is 100 centimeters per second square. So this would be like 10 to the power 3 and 2 5 zeros gram centimeter per second square. So by definition, this 1 Newton is equal to 10 to the power 5, and when gram centimeter per second square, by definition this is nothing but dyne. So therefore 1 Newton is equal to 10 to the power 5 dynes. Remember this equation. Okay, let's move further. So if a body is pivoted, like if you see the screen, the yellow shaded is the body which is pivoted at point A. That is, point A would not move. There won't be any displacement at point A. That is meant by pivoting a body. Okay. Remaining all points on the body can move, but at point A there won't be any displacement. If an external force is applied along at the point B, if external force is applied at point B, this is the external force that is applied on body at point B. Now what is going to happen? Because the body is not free to translate, it will tend to rotate, and it will tend to rotate about this, about an axis which is passing through this pivot A. Okay, so this effect of application of force is called moment of force, which is also called as torque. So moment of a force or torque is the turning effect produced by that force on the body about its axis of rotation. So the turning effect produced in a body due to application of external force about an axis passing through the pivot, or about an axis of rotation, is called moment of force, or it is also called as torque. Clear? This moment of force or torque is denoted by M, capital M, and it is obtained as magnitude of this force of the externally applied force into its perpendicular distance of line of action of force from the axis of rotation. So here the axis of rotation is passing through point A. The line of action of force is this. So the perpendicular distance is D here, as shown here. So the moment of a force is obtained as magnitude of the force into perpendicular distance of line of action of force from the axis of rotation. So this is measured in terms of Newton meter or kgf meter or dyne centimeter. These are the units for the moment of force. Okay, so likewise 1 Newton meter is equal to, so 1 Newton into 1 meter, that means 1 10 to the power 5 dynes. We know that 1 Newton is 10 to the power 5 dynes, and this is 100 centimeters. So this is nothing but 10 to the power 7 dyne centimeter. So 1 Newton meter is nothing but, if you convert in CGS units, it is 10 to the power 7 dyne centimeter. Okay. Now, moment of force is a vector quantity. Here, if the body tends to rotate clockwise, it is deemed to be positive. If the body tends to rotate anti-clockwise, it is deemed to be negative. So this attribution of sign is done to allow for algebraic summation of the moments. Clear? Okay, let's move further. Let us look at some daily life examples of moment of force. If you see on the screen, this is the elevation of a door and this is its top view. So when a person is applying pressure on or force on the knob of the door, see this knob of the door is at a distance from the pivot or hinge. So this distance is called the arm of the force or arm of the moment. So this force into this arm will give you the moment of this force applied on the knob. If you see carefully, if the knob is nearer to the hinge or the pivot, then greater force is required to produce the same moment because the arm of the moment has reduced. So if you are applying a force at a greater distance so that the arm of the moment is greater, then the force required to obtain same moment would be less. So if you try to open a door by applying force very near to the hinge, that is here, it would require a greater amount of force to turn the same door. Okay, likewise, this is a manual grinding stone. So if I draw the top view of this, so this is the pivot, this is the pivot actually, and this is the handle. So force is applied on this handle, and this would be the distance or the arm of the moment. So this force into arm will give you the moment of this force. So due to this moment, the grinding stone rotates in an anti-clockwise direction or clockwise direction, depending upon in which direction you are applying the force. Then if you look at a steering wheel, a driver will try to pull the steering wheel in this direction. So this would be the arm of the moment and this is the force. So due to this moment, the steering wheel is rotating in clockwise direction. Then the key, when you are turning the key, the force is applied here and this would be the arm of the moment or the distance of the line of action of force from point of rotation. So due to this, a turning effect causes the key to rotate in a clockwise direction. So when a mechanic is trying to open a nut, so he is applying force here. So this would be the arm, this would be the force. So here is the movement causes it to rotate in clockwise direction. So when a rider is riding a bicycle, so he through his foot he will apply force in this direction, which is at a perpendicular distance of d, this d shown here. So the moment is obtained by this force into this distance. Okay, so the moment of force its effect, like due to the application of external force, a turning effect is produced on body. So this turning effect depends on couple of points. One, the magnitude of the force. So the greater the force, greater would be the turning effect. Second, the distance or the arm of the movement. Like if the point of application is at a distance greater from the point of rotation, then the moment obtained is more. So movement of a force depends on magnitude of the force, that is greater the force, greater the movement, directly proportional. Then greater the distance or the arm of the movement, greater would be the moment. So these two are the factors on which uh, the movement, the movement of a force depends on. Then another point is the point of application of force. It also guides the direction of rotation. Suppose I apply the same force at this point, then the direction is reversed. So the body will tend to move anti-clockwise, assuming the pivot remains unchanged. Okay. Okay. So look around, and try to find out daily life examples of movement of force.